Okay, where in the code or what are the codes and the standards related to using cross-laminated timber? So we'll base this presentation off the 2018 IBC, but it certainly was in the 2015 IBC, and that was the first time it was adopted into the IBC code. And for those of you that aren't quite familiar with cross-laminated timber, this is a close-up look at it. And some people will say it's jumbo plywood, but it has laminations through the depth of the cross-laminated timber. And it's actually been around for quite some time, with the first patent being awarded in France in 1985. And then projects were built in Switzerland and Germany going back to 1993. And through the improvement of press technology and using CNC technology and incorporating it more into buildings so that the industry gets used to using cross-laminated timber, at least in Europe. We have the first multi-story residential construction in 1998 in Austria. And then throughout the 2000s, CLT was significantly increased in use. The main driving factor is the green building movement throughout Europe. And as I mentioned in the example of the Stadthaus project, the first 9-story the tallest CLT building in the world, that was one of the main drivers for using cross-laminated timber. But now there's over 500 CLT buildings in England alone. And as we mentioned in the beginning, it's recently come to the US and Canada where it's really taking off. So if you're familiar with wood construction, you're probably familiar with an engineered wood products and specifically glue laminated timber, where all the laminations are in the major axis, and the laminations are the individual members that are adhered together are glued together with adhesives. And this happens to be a balanced condition where we see the same grade of lumber top and bottom, and as we get through to the middle, we have lesser grades in the middle where we have less stress, and this acts in beam-like manner along the strong axis. But for cross-laminated timber, each of the layers we have one layer of the laminations in the strong direction, and then the next layer is 90 degrees to that, and so on. So that's why it's called cross-laminated timber. It's a thick orthotropic plate, and that cross-laminated timber, or the cross-lamination, provides some two-way action in that cross-laminated, in that panel. Now you see in the long direction where we have the major axis, that's where most likely the laminations are going to be in the long direction, where we're going to need the higher strength, where you have the highest stresses because it spans in the long direction. And then again, the inner ones are oriented 90 degrees to that. And when we're looking at walls, we can look at it two different types of applications of the loads. Well, there's actually three, but when we're talking about out of plane loading, we would see flatwise bending. So the design properties of out of plane or flatwise loading in CLT is now tabulated in PRG-320, 17, and 18. And that's the manufacturing standard for manufacturing cross-laminated timber. So they're now tabulated, and flatwise bending is bending of CLT under loads applied to the face of the wall in this application, or the face of the floor. And the design properties include ASD bending moments, average bending stiffness, and ASD shear capacity and average shear stiffness. And these all are tabulated in PRG 320 as a minimum qualification value for both the major and minor strength directions. And these will all need to be verified and obtained from the manufacturer. But note the terminology that I used about ASD, bending moment, et cetera, et cetera. This terminology is not consistent with the NDS, the 2018 NDS in Chapter 10 terminology, which is the chapter on CLT. And the reason is that the PRG-320 17 and 18 were developed after the NDS, the 2018 NDS was published. So we will most likely harmonize the language when the 2024 NDS is being developed. So that is flatwise bending or out of plane loading on the wall, and also loading on the floor, downward loading on the floor, or upward loading on the floor or roof. And then when we're talking about in-plane bending, this is properties for in-plane edgewise bending. It's going to require qualification testing per PRG-320. And remember when I talked about the header over the openings where it was infilled with glue laminated timber? And that is because some of the manufacturers have yet to develop their capacities or their design values for their cross-laminated timber. So the loads, the CLT is under loads is applied to the edge, is shown in this figure, in the edge of the panel, and then we have bending around this axis in plane, and it's these values are not tabulated in PRG 320 and must be obtained from the manufacturer. And that's why you will see the supplemental framing in that location, the header location, because there are no tabulated values in PRG 320. And note that the design values and section properties will require both major and minor axis directions. So the terminology, again, that you see here on the slide is different than what you would see in the 2018 NDS. But again, they'll be harmonized when we develop the 2024 NDS. These are some typical panel connections that you would see, typical angles, and these are self-tapping screws or wood screws that you would see. A lot the self-tapping screws are going to be proprietary type fasteners, so you would have to see the manufacturer, and they would probably most likely need to have an ER report or ESR report for the code official to approve them. And here are some typical connections that you might see on a job site where it's using cross-laminated timber, where we have members connecting or abutting. Imagine if this was a wall panel here, and that would be a balloon frame type connect panel, and then the wall, the floor connecting to the wall. Other applications, pretty simple applications or connections. Now for the panel to panel connection, when they sit side by side, at connecting the edges of the panels together to provide that continuity of load path, there are two typical type of connections because of the ease of constructing these type of connections. One is this single surface spline where the two panels would abut together, and then a spline of plywood or LVL will be used to splice the two members, the two CLT panels together. And of course, the screws would be connecting and continuing that load path from one panel to the other. The other one is using a half-lapped connection, and you would see that this does not require extra material other than the self-tapping screw to connect the two panels together. Now, how did it get into the 2015 IBC when it was first adopted into the 2000 IBC? Well, it had to go through the typical process of providing substantial information to substantiate the use of CLT under the code, looking at fire and structure. And American Wood Council did a fire test to show the fire resistance of the panel. And this shows you a test. And also FP Innovations also did some testing. That's a Canadian organization that provided some testing also to help provide information on using cross-laminated timber and the fire resistance. Now, the American Wood Council did an ASTM E119 fire endurance test, which is a test that is mentioned in the code that is used to provide information on how much fire endurance a product, any product that is used in a building that can be tested using this ASTM E119 test or standard test. And this panel had 5 plies of CLT, which is approximately 7 inches, and 5/8 type X gypsum on each side of the panel. And we had a 4x8 panel, 2 of them side by side with a half lap splice or half lap joint in the middle, and connected together with self-tapping screws. The test, they sought to get 2 hours of fire resistance rating, and it actually lasted for about 3 hours and 6 minutes. It was 3 hours, 5 minutes, and 57 seconds, actually. And it had 87,000 pounds of vertical load on the wall, and it surpassed the 2 hours of rating and went as far as 3 hours and 6 minutes, where we saw a structural failure where there was a buckling of the panel. But it certainly did exceed the 2 hours that was sought in the testing. And because of the test and other information that was provided to adopt CLT into the code, it was first adopted in the 2015 IBC as under type 4 construction, where you can see that it includes not only cross-laminated timber for the first time under heavy timber construction, but also structural composite lumber. But it also continues to be in the code in the 2018 code under type 4 construction. Now, type 4 construction, if for those of you that are not familiar with it, is the type of construction that has large wood members. They need to meet a minimum size that are prescribed in the code, and that's on the interior of the building, and the exterior of the building is required to have non-combustible walls that are made of non-combustible material, such as cold formed steel. But the code does allow fire retardant treated wood to be used in lieu of the non-combustible construction. And so no additional fire resistance is required for the interior of the building as long as those wood members meet the minimum requirements of the code for heavy timber construction. And there was information in Chapter 6 of the code in the 2015 that provides the minimum sizes that are needed to meet heavy timber construction. Under the 2018 code, that information has been migrated to Chapter 23, chapter on wood. Chapter 23 is wood. And so here's the table under the 2018 IBC that you would see. Now, under the 2015, this table was this much information in the 2015. Under the 2018, it's been expanded to provide more information to more easily read the requirements of heavy timber construction and the minimum dimensions. Now, in this table, it provides minimum dimensions or nominal dimensions for solid sawn lumber. For example, 6x6 is what we would call for sawn lumber, which is 5.5 inches by 5.5 inches. And then we have glue laminated net sizes. That's the actual size, or the minimum size for the glue laminated net size. And then we also have it for structural composite lumber. Now, new to the 2018 are these two columns, which really state what members, well, first, what the heavy timber structure member is, and then what loads it's supporting. So this information was actually in the body of Chapter 6, where it was talks about the minimum sizes for heavy timber construction. But now it just was migrated into the table to make it easier to understand the minimum requirements. And you notice that cross-laminated timber is not in this table, and that's because there are minimum thicknesses that are in the body of the language in Chapter 23, Section 2304 for heavy timber construction. And again, no additional fire resistance is required because of the long history of heavy timber construction and its wood's innate ability to slow down the speed of fire for the wood member. And I'll mention something more about this later on in the presentation. Now, so where can cross-laminated timber be used in the code? Well, certainly, as I mentioned, under Type 4 construction, all elements can actually be constructed out of cross-laminated timber, and no additional fire resistance is required for the interior of the building, provided it meets the minimum sizes. So, as I mentioned, the exterior walls for heavy timber construction or Type 4 construction are required to be non-combustible construction, but we are allowed to use fire retardant treated wood, or you can use cross-laminated timber with fire retardant treated plywood on over the cross-laminated timber, or it needs to be protected by gypsum. And then the floors and the roof may be of cross-laminated timber, provided it meets the minimum thickness shown here. And then the interior walls can be cross-laminated timber as long as they're 4 inches thick. And in addition to cross-laminated timber, nail laminated timber, which is another type of wood product or wood construction, can be used in this situation in Type 4 construction. And then Type 3 construction. Typically, you would see Type 3 construction in mid-rise construction, or I've seen it used in restaurants and other types of construction. Well, it can actually be used for other occupancies, but it is typically used for mid-rise construction, where you see 5 stories of wood construction over 1 level of concrete podium. So for this type of construction, it requires that the exterior walls be of non-combustible material, but the interior of the building elements can be of any material permitted by the code. And the code allows cross-laminated timber. So the interior can be of cross-laminated timber. And let me go back to the other slide, the section related to the exterior walls. Now, it does say that fire retardant treated wood framing and sheathing shall be permitted to be used at the exterior wall assembly of 2-hour rating or less. And so opening up the door for the use of wood in all wood building. And so for Type 3 construction, CLT can be used almost everywhere. And specifically on the interior, it can use cross-laminated timber, and the roof can be of cross-laminated timber. And then the exterior walls can be constructed of fire retardant treated wood, provided the exterior walls are the requirement is 2-hour fire resistance or less. And then Type 4 construction. Type 5 construction allows any materials permitted in the code. So certainly cross-laminated timber is permitted in the code and can be used in Type 5 construction. So anywhere, exterior walls, the floors, the roof, and the interior walls. So we have a poll, and we'll go ahead and launch this poll.
So which of the following is the tallest mass timber structure in North America? The Stadthaus, the Brock Commons, the Arborer, or the Origin?
Okay. And the key to this poll is that it is North America. So when we talk about North America, Brock Commons is the tallest, and
Right.
that it's 18 stories tall. Okay. Okay, so the code. In the 2018 IBC, it references the 2018 NDS. And we talked about mass timber construction. Mass timber construction can utilize all of these wood products to create large wood elements. Sawn lumber can be used to create the nail laminated timber. We have structural glue laminated timber, structural composite lumber, all and glue laminated timber all can be used in heavy timber construction and other types of construction. So these are the chapters that are applicable to mass timber construction wood products. And Chapter 10 is where we see cross-laminated timber, and that was new under the 2015 NDS, where we have cross-laminated timber. So we have the charging language in Chapter 10, Section 10.1.1 for utilizing engineering design with performance-rated cross-laminated timber. And important to note and to put on your drawings if you're designing cross-laminated timber or using cross-laminated timber is the manufacturing standard, the standard for performance-rated cross-laminated timber, which is the ANSI APA PRG-320. And for the 2018 IBC and 2018 NDS, it references the ANSI APA PRG-320 and 2017. And this is applicable under the current codes to the low and mid-rise buildings using CLT. That would be under type 3, type 4, and type 5 construction, which is permitted under using those types of construction. Now, one thing to note though is if you are going to go taller with your structure, and there is a or a more current standard, which is the APA PRG-320 2018. And this is the one that's referenced in the 2021 code, IBC code. And so this is applicable for types 3, types 4 heavy timber, and types 5 construction. And under the 2021 code, there will be an expansion of heavy timber construction to type 4A, type 4B, and type 4C. So type 4 heavy timber is the traditional heavy timber construction. Type 4A and type 4B and type 4C allow for the use of mass timber construction to go to higher heights than what is currently permitted in the code. And they have various levels of suppression, sprinkler requirements, protection of the mass timber, et cetera, et cetera. So we do have a webinar that will be coming up in June that will go over the code changes that have been adopted and approved in the 2021 code. We had a webinar also last year in 2018, in June 2018, that went over the actual code changes. And the reason we point this out of utilizing the ANSI APA PRG-320 2018 is if you are going to be designing taller mass timber construction using cross-laminated timber, taller than what is currently permitted in the code, you really should use the 2018 version of the PRG-320. And that is because the adhesive requirements to prevent fire regrowth was changed in PRG 320. And that's the standard that was used to develop the CLT panels that were tested successfully in the full-size test when the ad hoc committee was looking at cross-laminated timber and developing the 14 code changes. So again, going to tall or doing mid-rise construction that is currently allowed in the code, ANSI PRG 320 2017 is applicable. If you're going higher than that, then specify ANSI PRG 320 2018. And as of March, we were told that 4 of the 6 APA CLT manufacturers are manufacturing CLT per the 2018 version. And it looks like the remaining 2 will be manufacturing in July, probably by July 2019. So when we get our cross-laminated timber, we will want to have those panels stamped, similar with other wood products. Here's an example of a stamp that a product marking that you would see that gives you information on who produced or manufactured where it was milled with an identification number, and the CLT thickness or identification, the CLT layup, the approving agency name or logo. This one happens to be APA. And then also the reference product standard. This one is the ANSI APA PRG 320 2017. Additionally, if you are specifying a panel that is unbalanced, now most panels are going to be balanced, where you have the same grade of lumber top and bottom, and it's balanced throughout the depth of the CLT panel. But there may be some time where you would specify a panel that is unbalanced layup. And if that is the case, you want to specify that the panel will need to have a stamp on it that stamps it as top, so that when they're erecting this out in the field, they'll know which way is up and down on the panel and hopefully erect it correctly, with the stamp top being on the top of the cross-laminated timber. Now, the panels come in various thicknesses. The laminations are 5/8 inch to 2 inches thick, and they're made of sawn lumber or structural composite lumber. The maximum thickness is 20 inches maximum, and then the in-service moisture content that is assumed under the NDS and the standards is moisture content, in-service moisture content of 16%. And that's similar to what you would see for glue laminated timber also. So the reference design values, where do we go to get the reference design values? Well, according to the NDS, you would either see the cross-laminated timber manufacturer's literature or obtain it from the code evaluation report. And the APA website is a really helpful website for obtaining information on cross-laminated timbers. And here is the actual link to this one web page, which you will see on the right-hand column. It lists the members that manufacture cross-laminated timber. And then also on the right-hand column are a list of the CLT product reports that will give you some information on each of the individual manufactured CLT products. Here's an example of the CLT products. And one thing to note is that APA does produce product evaluation reports that are shown here, and they went into an agreement with ICC back in 2012 to have reports that are jointly produced with APA and ICC. Now, these are just through APA, but an APA member can have an APA product report or an ICC ESR report or a joint report, as I mentioned. And but I don't think there are very many CLT manufacturers that have that joint report. And mostly they're going to be I-joist or structured composite lumber that have that joint report. Now, just like any other wood products, the Cross-laminated timber has its own table for the applicable adjustment factors for cross-laminated timber, depending on whether you're using an ASD ASD or an LRFD design. For ASD, you would use the gray area and all of these applicable adjustment factors, depending on what mode of that you're looking at, if you're looking at bending, tension, shear, etc. And those are consistent with what you would see, as I mentioned, in with other products. This one actually is modeled after the wood structural panels, similar to that. And then we have updated back in 2015 NDS the provisions for connections. This one is Chapter 12 to include cross-laminated timber connections. So see that if you're designing your connections. It provides information on fasteners in withdrawal and lateral loads on fasteners, minimum spacing requirements, etc. Now, what about lateral design for cross-laminated timber buildings? Well, for seismic design, there is no response modification coefficient, an R factor that is in ASCE 716. And CLT is just not recognized as a system in Table 12.2-1. But there are options, and that is that doing a performance-based design procedure per ASCE 7, demonstrating equivalency to an existing ASCE 7 system such as, say, brace frame, or buckler brace frame, etc. And then there's other information related to using cross-laminated timber. But the other option is to use a system that's already prescribed in ASCE 7. I showed you the carbon 12 building that had cross-laminated timber floors, and it used buckling restraint frames for its vertical lateral resisting system. So that's certainly an option. I've also seen projects where they used just regular brace frames or used moment frames as the vertical lateral resisting system. As far as in-plane shear for lateral loads, again, there is no R value and currently no seismic R factor, but there's ongoing research and standards development on CLT shear walls. The timing, as we understand it, is that the ASCE 722 would be the earliest that a seismic R factor would be codified. Now, there are provisions for CLT shear walls for wind design that are being developed for the 2021 special design provisions for wind and seismic. They're working on it right now, which will be referenced in the 2021 IBC. But in the interim, lateral design using CLT would have to be approved via an alternate means and methods. And fire design, I mentioned that for heavy timber construction, type 4 construction, as long as the wood members meet the minimum prescribed dimensions in the code, there is no additional fire resistance needed for those wood members. In other words, no additional gypsum is required or no calculated fire resistance. So this is prescribed in the code under section 722, calculated fire resistance. And it states that the calculated fire resistance of exposed wood members and wood decking shall be permitted in accordance with Chapter 16 of ANSI AWC National Design Specifications for Wood Construction. So it specifically mentions Chapter 16. And fire resistance, you'll work with the architect who will let you know how much fire resistance is required for the elements in the building. And you can calculate up to 2 hours of fire resistance for columns, beams, and tension members. This can be done for lumber, glue-laminated timber, structural composite lumber, decking, and CLT. And this was true for the 2015 IBC and NDS. And what we're doing is we're calculating the amount of char that is needed to build up the char or a sacrificial layer to provide a certain amount of fire resistance up to 2 hours. And this is an example of fire performance test that was done that tested a steel beam versus a glue laminated timber beam. And they were both the same amount of strength at the start of the test. And as you can see, that the steel beam probably lost about maybe 60% of its strength, where the glue laminated timber beam lost only about 20% of its strength. So this is an analogous of comparing type 2B construction, which is typically steel or concrete, but 2B meaning not no fire resistance rating required for the steel beam versus a heavy timber construction, kind of a similar type of comparison. Now what we do is we calculate the amount of char that is built into the member, and it slows down the fire to the amount of time that's required, and then there's an inner zone. So we calculate this char, and it's an effective char, and then we take the net section and calculate the structural capacity for fire design of the wood member. And Lori will go into detail on how to perform this type of calculations for the wall. And as mentioned, it's in chapter 16, and using nail laminated timber, glue laminated timber, and cross-laminated timber. Those are the members that are typical of mass timber construction. There's an adjustment factor table just for fire design, and this table lists the values of K for various mode capacities to adjust it to an ultimate strength basis. We have a TR10 report that provides more in-depth information, background on the NDS, and has design examples that covers decking, glue laminated timber, and cross-laminated timber, to name a few, and then also provides information on the background, the testing that was performed. Now, this is the equation that will be used for determining the A char, which is the char for when it is exposed to fire. So for cross-laminated timber of laminations of equal thickness, the char depth A char is shown here. And the char rate, which is beta sub n, what is typically used is 1.5 inches per hour is commonly used for cross-laminated timber and other wood products. And the section properties are calculated using standardized equations for the area. So you take the net section, determine your section properties after you know the A effective, which is shown here. Now, A effective is 1.2 times A char. And the NDS uses a nonlinear char rate with a 1.2 increase to account for elevated temperatures in the zone where you have, let me go back to the picture previous to this. So you have an A char and then an A effective that accounts for this elevated temperatures near the cold wood, between the heat zone and the cold wood, the 20% increase. We have a handy table that takes into account utilizing a char rate of 1.5 inches per hour, and this is for equal laminations that gives you your effective char. For example, for 1 hour of fire resistance rating and the laminations are 1.5 inches, we need to build into the effective char depth of 1.8 inches into our member. And then there's also a table for other members such as sawn lumber, glue laminated timber, and structural composite lumber shown here. So the important thing to note is that when we're looking at cross-laminated timber or any type of member that we're calculating fire resistance, we want to make sure not only that we build in that char into our member, but we will also want to look at the system and make sure that the connections, whatever is supporting that cross-laminated timber or glue-laminated timber, that the connection is protected for the same amount of fire resistance as we calculated for the member. So wood connections, including the connectors, fasteners, and portions of the wood member included in the connection design shall be protected by the same amount of fire resistance. And that can be done using either wood, fire-rated gypsum board, or other approved materials to protect the connection. Now this is a wall, just a graphic of the wall if we have a vertical load, and we will calculate the char depth, and Lori will go through this in more detail, but we're using a stepwise approach where we calculate the char and then determine the net section, which is shown here. And that net section, we have this heat zone and then a 20% increase for the difference at that heated zone area. And then we have a net section. Now, when we look at this, we look at the net section, but we don't take into account the laminations that are in and out of the slide, because we don't want to take that into our determining our cross section and use it for calculating our structural capacity, to be a little bit on the conservative side. Let me see here. And so just a graphic to show you the net section shown here. And taking out the laminations going in and out of the slide, and that's our net section. And obviously the neutral axis will shift. Once we have our next section, we would get our capacities from the manufacturer. Now, Lori will be taking a conservative approach and utilizing the capacities from PRG-320. That's just to give an approximation. If you're really designing this, you need to go to the manufacturer with that next section, and they will provide you with the design properties. So we have one more poll that we'll look and launch here.
The following information may be found on a CLT product bark. Is that panel layup, panel thickness, width and length, mill name, grade of laminations, answers A and C. All right, so 88% say answers A and C, and just a little bit on the other answers. So Michelle, why don't you let us know what the real answer is?
And the answer is, let's do the animation, A and C, panel layup and mill name. So the width and length will not be on the product stamp, and you'll have the mill name and not the grade of the individual laminations. So we'll go ahead and hand it over to Lori, who will be doing the step-by-step example of the cross-laminated timber wall.